Right, so here's a pulley question. I've got two particles, P and Q, suspended from a pulley. Key phrase that they've used is that this is a smooth pulley. Okay, and that's going to let us make some assumptions later on. Right, so when they're released, Q is going to descend with acceleration of 1/3 g. Okay, now the other thing to bear in mind is that as that particle descends, what's going to happen to this particle? That's going to ascend. Okay, because remember they're fixed together by an inextensible string, so obviously they're going to move together. Right. Okay, so first thing, A, it says calculate the tension in the string as Q descends. So we're just interested in Q. Remember, if we look at the whole system, tensions will actually cancel out. So we've got our particle, and that's on the end of a string, and there is tension from the string. And what forces are acting downwards? Well, that's just the mass times g. Okay, so this is our Q. Right, so let's set up our F equals ma equation. We've got to pick which direction to resolve in. I'm going to resolve upwards because I want tension to be positive. So my tension is going upwards minus weight times gravity, which is going down. And that's my forces. Then I've got my mass of 3m. And I multiply that by acceleration. Now, acceleration is going down. So acceleration is negative. So it's negative 1/3 g. Okay. So if I put 3mg, now I've got 3m times minus 1/3 g, which means that that is minus mg. Now I'm going to add 3mg to both sides, so that means that T is going to be equal to 2mg. So that's A taken care of. Okay, now part B. Now it's asking us to find K, to show that K is 1.5, and K is the mass of the particle P. Okay, right, so now, again, we're going to use the fact that it's part of a system, so we can use the tension. So I'm going to use the fact that that's the tension, and then we've just got kmg acting downwards. So again, I'm going to pick my direction. I'm going to pick it to go in this direction. So T, again, is going up, minus mass times gravity, down. That equals my mass times acceleration. So that's just km times acceleration. Now, remember, as Q goes down, P goes up. So acceleration of that in the upward direction is going to be positive 1/3 g. Right, so again, let's simplify that. So I've got T, I'm going to add kmg to both sides, plus 1/3 kmg. So that means if I put those two together, I've got 4/3 kmg. Okay, now remember that we just worked out that tension was equal to 2mg. Let's substitute that into the second part. So now it's going to be 2mg equals 4/3 kmg. Okay, well, both sides are multiplied by mg, so I can divide both sides by mg. So now 2 is equal to 4/3 of k. So if I divide both sides by k, I get that k is equal to 3/2, which is 1.5. So that is my B taken care of. Now all we're left with is C, and C says state how you've used the information the pulley is smooth. Okay, so if the pulley is smooth, then the acceleration of P equals the acceleration of Q. It basically means as that one goes down, it pulls that one up. And they're going to move at the same speed because the pulley doesn't interfere. The pulley lets the string move freely. So the acceleration of these two are matched. And that was the point that we used here when we substitute in the same tension. Okay, because the tension and the acceleration are going to be the same. We use this as a negative here and a positive here. That's it.